This concept is literal equations. So we're going to take a bit and talk about what is a literal equation. And all it is, it's an equation with multiple variables. Before, we've been solving for x. So basically what we're doing is we're just getting x by itself on the left-hand side of the equation, and then we get a constant term on the right. With the literal equation, now we're going to decide what variable are we solving for. Basically, what variable do you want to bring on the left side of the equation? Again, the only two properties that we're going to be using are additive inverse and multiplicative inverse. So, in those property of equalities. So, for example, we've been solving for x. How do you get x by itself? You clear out your constant term, you zero it out with additive inverse, add on both sides for equality. So I get 2x equals 18. And then, of course, I divide both sides by 2 to get x by itself, and x equals 9. When you separate a coefficient from a variable, that's division, right? When you clear it out, that's additive inverse. So if I wanted to get x by itself over here, I'm going to do the same thing. Except now I got to clear out this negative b. I do that by additive inverse. I add b on both sides. And I have ax equals, now, can I combine unlike terms? No, I cannot. So I'm going to keep them separated. So it's b plus c. And then to separate a from x is division. So I divide both sides by a. And I get b plus c all over a. So it's the same thing. I add to both sides additive inverse, and then I separate by division. So if you look at what the similarities are, is that, well, we use the same properties in both of them. So we use additive inverse, we use division property of equality. How are they different? Well, literal equations are just variables. That's it. But it's the same properties. Okay? So let's take a look at some more examples together. So if I want to get w by itself, I have to separate it from L. So I'm going to divide both sides by L. My L's cancel out, and I have A over L equals W. However, I'm going to use symmetric property here. I don't want the variable I'm solving for on the right-hand side. So I'm going to move it to the other side, so W equals A over L. And that's my answer. Okay? Now, if I want to solve for T here, I have to separate it from R. So I separate it by division. So I'm going to divide both sides by R. My R's cancel out. I have D over R equals T. Are you going to give it to me like that? No, you're not. You're going to use symmetric property to put T equals D over R. And that's my final answer. Look at number 5. If I want to get H by itself, I'm still using division. Now, I'm going to make it simple. I'm going to divide both sides by L and W at the same time. That's fine. So I divide by L and W. That way my L's cancel out, my W's cancel out. I'm left with H, and I have V over LW. You're not going to give it to me like that. You're going to use symmetric property, and I have H equals V over LW. That's my final answer. Okay? Look at here at number 7. If I want to get C by itself, I have to clear out this S. It's separated by a subtraction sign, so that's additive inverse because I have to clear it out. I have to zero it out. So I'm going to add S to both sides. Can I combine M and S together? I can't. They're unlike terms. So I'm going to do M plus S equals C, but symmetric property says C equals M plus S. Okay, that's my final answer. If you jump over here, let's look at number 6. If I want to get R by itself, I'm going to divide both sides by pi, and I get A over pi equals R squared. What is the opposite of squaring something? Do you remember this inverse property from last year? You take the square root of both sides. So to clear out, to get r by itself, I have to get rid of this squared. So I'm going to square root both sides. My square root and square cancel out to leave me with r. And then that's your answer right there. So r equals the square root of big A over pi. Okay? All right, let's take a look down here. How do you get m by itself? Multiplicative inverse. You multiply both sides by v. I put v on top so you can see that my numerator and denominator cancel out. Whatever you do to one side, you do to the other side. So I have dv equals m. Symmetric property says m equals big D little v. All right, let's go to the next page and take a look at some more. Okay, so if I want to get h by itself, I want to clear out my fraction first. And how do you clear out your fraction? Just like we've been doing before. I use multiplicative inverse. So I multiply by 2 on both sides. My 2's cancel out, and I'm left with 2a equals bh. And then to get h by itself, we do what we did above. We divide, we separate both sides by b. So I get h equals 2a over b. B's cancel out. Okay? All right, let's take a look at number 10. I want to clear out my fraction first, so I'm going to multiply both sides by 3. And I get 3v equals big B times h. My 3's have canceled. And if I want to get big B by itself, I have to divide both sides by h. H cancels out, and I have 3v over h equals big B. However, symmetric property says b equals 3v over h. And I've gotten that by itself. All right, let's take a look at number 11. If I want to get m by itself, I clear out my fraction, so I'm going to multiply both sides by 2. I get 2k equals mv squared. Notice I'm going for m here, so I'm going to divide out v squared. That's how they cancel out. V squared. My v squareds cancel out. I'm going to use the symmetric property here and say that m equals 2k over v squared. So of course you want to identify what variable you're solving for first. So over here, if I want to solve for b, okay, I still have to clear out my fraction first. That doesn't change. And I'm going to multiply both sides by d. So a times d is ad. You can see my d's cancel out. I'm left with b plus c. And how do I get rid of this positive c? Additive inverse. I have to subtract c on both sides. These are unlike terms. This is a term and this is a term, and they're not alike, so you have to keep them separated. So AD minus C equals B. However, symmetric property says B equals AD minus C, and that's my final answer. All right, let's take a look at 13. If I want to get W by itself, I need to clear out this whole term first. How do you clear out this positive 2L? You subtract 2L. Additive inverse, you clear it out. Clearing it out is additive inverse. Separating is division or multiplicative inverse. So I subtract 2L on both sides. Unlike terms, so P minus 2L equals 2W. If I'm getting W by itself, I'm going to separate it, divide it by 2. That way my 2's cancel out. I'm going to use the symmetric property. And notice I'm dividing everything on the other side by 2. So I get W equals P minus 2L over 2. That's my final answer. Additive inverse and multiplicative inverse. That's all I'm using here. All right, let's take a look at number 15. If I want to get X by itself, I have to clear out this B. I got to get rid of it. So I'm going to additive inverse on both sides. My B's cancel out. Unlike terms, so y minus b equals mx. And then to get x by itself, I separate m from it. Separate is by division. So I divide everything by m. And this is what I'm left with. I'm going to use symmetric property to say x equals y minus b over m. And that's my final answer there. Okay? All right, let's take a look over at 16. Very similar. I want to clear out this p first. So I subtract p on both sides. And I get a minus p, unlike terms, equals prt. My goal is to get t by itself. So I need to separate all of pr. So those guys cancel out. And whatever you do to one side, you do to the other side. And now I'm going to use symmetric property and say T equals A minus P over PR as my final answer. Let's take a look at number 17. So here, I still want to clear out my fraction first. So I'm going to multiply by the multiplicative inverse. That doesn't change. So multiply both sides by 9/5. Coefficient goes in front. So 9/5 C equals F minus 32. And then, of course, to get F by itself, I have to get rid of this negative 32. How do I get rid of a negative 32? I add 32 on both sides. Again, these are unlike terms. I can't combine them. So I have 9/5 C plus 32 equals F. You're not going to give it to me that way. You're going to use symmetric property to say F equals 9/5 C plus 32. Okay? All right, let's take a look at 18. I'm going for B1 here. I still want to clear out my fraction, multiplicative inverse, so I multiply both sides by 2. Whatever you do to one side, you do to the other side. That's that equality property. And I get 2A equals H times B1 plus B2. I want to separate that H, right? So separate means division. So I'm going to divide both sides by H. And here's where I am. My goal is to get B1 by itself. So how do you clear out B2? Additive inverse. You're going to subtract B2 on both sides. Now, these are unlike terms, okay? You can't combine them. 2A over H is one term, and then I subtracted B2, and that's what's equal to B1. You're not going to give it to me like this. I want it symmetric property, so B1 equals 2A over H minus B2. And that's my final answer, okay? So slow this video down clearly. I taught you fast, but make sure you understand those steps. Steps are the same as we've been doing. Additive inverse, multiplicative inverse, properties of equality. Whatever you do on one side, you do on the other. Okay, so a little bit different with variables, but still the same properties we've been using since day one. If you need help, come and see me.